All right, guys. Today is going to be more of like an edit to a previous video, specifically the domain and range 4 video. If you watch that one, you'll notice that I didn't correctly solve, or I didn't correctly find the domain and range for x squared minus 3x. So I'll make sure to plug this edit into the video also, so that if you go and review it, you'll know where to go to find this specific example. So what we're going to do is we're going to find the domain and the range, right? So find domain and range. Okay. Now, we know about square root functions. We know that the range is always we'll get that out of the way right now. For square root functions, the range is always going to be including 0 to positive infinity. The domain is the hard part here. We have to figure out what x can equal, and how we do that is we say, well, under the square root symbol, that expression, in this case x squared minus 3x, has to be greater than or equal to 0. Okay, so the best way to do this, since we can't directly solve for x in this form, we're going to have to factor it. And so let's just factor out the x's first to get a better picture of where the zeros are at for this expression, right? And so when I factor, I get my critical points, right? So this means that if this expression equals 0, so if it equals 0, then one of these has to be 0 as well, right? So we can say critical point, and I'll write this here, critical points, x equals 0, and when we solve the other one, x minus 3 equals 0, we get x equals positive 3, right? So let's draw a number line. We have 0, we have 3, and what I'm going to do is just test different values to kind of see the behavior around these critical points. So let's just start with left of 0. What happens? So if we have a negative 1 in here, in this expression, let's just say, this is the x-axis, what is y of negative 1? And it looks like this comes out to be the square root. We have a square here. 1 minus negative 3. And that just equals the square root of 4, which is a real value. So we have real values here because they're positive. Similarly, now let's look at the interval between 0 and 3 to see what's going on here. Also, this is positive, right? So I'll just write positive as well. Let's try 1. Let's just try positive 1 because it's in between 0 and 3, our two critical points. So if we say y of positive 1, well, that is going to equal 1 squared minus 3 times 1. We can already see right here that we're getting an imaginary number. And that means that the function is not real valued between those critical points. Once we've checked one value in an interval whose endpoints are defined by at least one critical point, we don't have to take the other values. We know that the function will have that same behavior within this interval. And so we have imaginary numbers, and then and we can't really say it's negative. We just say that it is complex valued. And so the domain does not include this region here with this complex values of y. Now let's check the right-hand region over here, right of the critical point x equals 3. Let's just use 4 because it's just one more than 3. Let's just keep it simple. We could really choose any number bigger than 3, but I want to keep this simple. We have 4 squared minus 3 times 4. That equals the square root of positive 4, which is in fact a real value. And also, it's positive, right? And so the behavior of this function, we know that the square root function, it looks something like this. Right, and so if we have, if we just had x squared minus 3, this would just shift the graph over to this way, right? And then x squared minus 3x, so the square root of x squared minus 3x, it's just going to, adding that little x onto the 3, that x factor onto the 3, will just kind of make it a little more lower. But you'll still have that same kind of square root shape. And then similarly, for the x equals 0 point, it's going to go off that way. And so what we have here is this shoots off to negative infinity. This is 0, this is 3, and this goes to positive infinity. And we can therefore say that our domain, D, is negative infinity to 0 union 3 to positive infinity. So really, for our domain, we just stay out of that interval. That interval is not valid for this expression, and we get our domain as being this 2-interval expression. And then our range for square root functions is always this. So it's always the same for square root functions. All right, and so that's going to wrap up this video for the day. I hope you guys learned something. If you enjoyed the video, please like and subscribe and hit the bell notification such that you may be notified next time I make another video, which will be very soon. And that'll be all for today. So thank you for watching.